Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like Introduction to RUP, basic concepts, symptoms in software development and their root causes. Let's get started. Slide 1, Introduction to RUP, Rational Unified Process. Let's start with understanding what RUP, Rational Unified Process, actually is. RUP is a structured software development methodology that helps teams plan, develop, and deploy software systematically. It's not just a set of random guidelines but a well-organized process framework that ensures software is delivered on time, within budget, and with good quality. Two important things about RUP. It is iterative, meaning instead of building the entire software in one go, we build it in repeated cycles where each cycle adds value. It is incremental, meaning we add features gradually, building up the software in small parts. RUP is also object-oriented, so it emphasizes working with objects and classes, and it uses UML diagrams to model and plan the software. An important point to note is that RUP was developed by Rational Software, which was later acquired by IBM, so many IBM tools support RUP. Example: imagine developing a banking application. You don't build all features at once. First, you build login, then accounts, then transactions, etc. This is iterative and incremental development, and RUP guides how to do it systematically. Slide 2. Basic concepts of RUP. Now, let's break down the core components of RUP to understand how it works. 1. Phases. RUP divides the entire software development into 4 distinct phases: inception, elaboration, construction, and transition. Each phase has its purpose. Point 2. Disciplines or workflows. These are different sets of activities such as requirements gathering, design, development, testing, and deployment. 3. Artifacts. These are outputs or deliverables like requirement documents, UML diagrams, code, and test cases that are created during the process. Point 4. Roles. These define who does what. Roles include developers, testers, architects, analysts, and project managers. 5. Activities. These are tasks assigned to different roles, like coding, designing, testing, reviewing. Point 6. Iteration. The development happens in cycles, where each iteration delivers a part of the software and allows improvements based on feedback. 7. Best practices. RUP promotes industry-standard practices such as develop iteratively, manage requirements, use visual modeling, verify quality, and control changes. Significance. These components ensure that large and complex projects are handled efficiently and that all team members know their responsibilities clearly. Slide 3. RUP phases explained. Now let's dive deeper into the 4 main phases of RUP. 1. Inception phase. The goal is to define what the project is about, its scope, objectives, risks, and cost estimate. Example: if building a banking app, we define what features like transactions, account details, etc. are required. 2. Elaboration phase. Here, we analyze the detailed requirements, plan architecture, and address major risks. Example: deciding on backend technology like Java or .NET, and designing system modules. 3. Construction phase. This is where actual coding happens. Software components are developed, integrated, and tested. Example: developing login, fund transfer, and statement modules. 4. Transition phase. Focuses on deploying the system, training users, and fixing remaining issues. Example: making the app live for users and handling feedback. Significance. Breaking development into these phases ensures systematic growth and effective risk management rather than rushing through the process. Slide 4. Symptoms in software development process. Next, Let's identify common issues, symptoms, that appear when software projects go wrong. These are like warning signs. 1. Frequent project delays. Deadlines are missed regularly, showing poor time estimation. 2. Budget overruns. Cost of the project goes beyond planned budget due to improper resource planning. 3. Poor software quality, resulting in frequent bugs and crashes, showing lack of proper testing. 4. Unclear requirements, changes and confusion about what needs to be built, leading to mismatches between what is developed and what is needed. 5. Weak system design, architecture that cannot handle future growth or change easily. 6. Inefficient communication, teams working in silos without understanding each other's work. 7. Low user satisfaction, software that doesn't meet user needs or is difficult to use. 8. Rework and fixing issues, continuous corrections due to bad initial planning. 9. Missing documentation, absence of essential guides and specifications for future reference. Example: if a client wants a feature and the development team misunderstands it, wrong functionality may be built, causing delays and frustration. Slide 5. Root causes of software development problems. Let's now analyze why these symptoms occur, the root causes behind software failures. 1. Unclear or changing requirements. If requirements are not gathered and fixed properly, they will keep changing, confusing developers. 2. Lack of proper planning. Without planning, there's no clear direction, leading to chaos. 3. Poor team communication. When developers, testers, and clients don't talk frequently, assumptions and misunderstandings occur. 4. Inadequate risk management. Ignoring risks like technology limitations or staffing issues causes problems later. 5. Weak system design. If the system is poorly designed, any small change becomes difficult, causing delays and errors. 6. Lack of skilled staff. If team members are not trained, quality suffers. 7. Wrong time and cost estimates. Underestimating time or cost leads to budget overshoot and incomplete features. 8. Skipping testing leads to buggy and unreliable software. 9. Not following iterations. Trying to build everything in one go without feedback leads to poor results. Example: if developers are not aware of potential technology limitations in early phases, it can cause major problems during coding or deployment. Slide 6. Advantages and disadvantages of RUP. Advantages of RUP. 1. Iterative development. Allows incremental progress and corrections at each stage. 2. Early risk handling. Identifies and resolves risks before they become major issues. 3. Improved quality. Ensures regular testing and architecture reviews. 4. Clear roles and activities. Everyone knows what to do, reducing confusion. 5. Good for large projects. Suitable for complex systems that need structured management. 6. Strong architectural focus. Ensures the system is well designed and maintainable. 7. Customer involvement. Frequent feedback loops ensure that customer needs are met. 8. Better control and monitoring. Defined phases and documentation help in managing progress. 9. Use case driven. Focus on what users need, improving satisfaction. Disadvantages of RUP. 1. Process complexity. Can be too heavy for small or simple projects. 2. High cost. Requires trained teams and often licensed tools. 3. Steep learning curve. Team needs time to understand and follow RUP. 4. Time consuming. Formal processes can slow things down. 5. Tool dependency. Often tied to IBM rational tools, increasing cost. 6. Needs expert managers. Incorrect use can create more issues. 7. Hard to tailor for small teams. RUP is designed for large teams, making it difficult to scale down. 8. Too much documentation, more paperwork than agile methods. 9. Not fast for quick deliveries, slower compared to agile or lean approaches.